All right, hey everybody here, Mr. Ford here, and welcome to class. We got Thursday, April 18th, 2024. We got ourselves a do now. Now, I know you're watching this video late because you had the assembly. You got to think about it like you were absent today. Block 6 has already had this lesson. It's great. It was award winning. That's why you're watching now. You're doing section 9.1.2, solving quadratic equations using the quadratic formula, the granddaddy of them all. Kind of most well-known way of solving quadratic equations. And we've already talked about three ways. Last class, we talked about again. We've been doing zero product property for a while. We've been doing completing the square just a few classes. And take the square. There's also graphing, right? Using Desmos graphing method. So you get kind of most well-known one today, but we have other ways to do it. Here is your do now. Jump on into it right now. You got your do now complete problems 9.4 and 9.5 on page 419. I'm going to check homework as you guys do the do now, like usual. Okay, so you're opening up page 419, do problems 9.4 and 9.5. Those are from the last lesson. We didn't get to them, so we able to do them. I'm checking homework right now. Excuse me, sir. You have your homework. Okay. One person who shows up to class does not have their homework. What is the odds of that? Okay, problems 9.4 and 9.5. Do them. All right. Anyways, homework answers are here. Okay, they're here. You're not going to be able to see them. Okay. These you did your homework on Tuesday, because Tuesday night, right? That's not the homework. I know you do your homework. When I post the week 14 assignment on Google Classroom, that's where you're going to take pictures of your work on these problems, 9.6 to 9.10, sorry, 9.11, and just submit a picture to me so we can get those checked out. You can get your 5 points there. Okay, so homework answers. The thing that I was checking, most people in block 6 got this correct. I was checking 9.6 part A on the homework. Okay, that was assigned on Tuesday. And that one here, the answer should be -2 and -26 for W. Once you complete that square, you need to get to 14 squared, which is 196. Okay, you only have 52 here, so you got to add 144 to both sides, take the square root, remember plus or minus. So anyways, you're basically doing this to do now. Questions 9.4 and 9.5, same thing you do for homework. Okay, so get that do now going. There's the do now. Okay, so what I'm going to do, hopefully you're doing this do now. This is solving the following equation using Cure's method from yesterday's class, well, Tuesday's class, I mean there. Use generic rectangles to help you complete the square. So this is problem 9.4. You're doing part A, which is right here, and then you're doing part B. Now, if you are trying to follow the video or trying to do it on your own, it's kind of distracting to watch the video and try math as well. So pause the video, try both these problems, and then we'll go over them when you unpause. Okay. All right. Very nice here. Let's go ahead and go on over this now that you've tried this. I have somebody who's here who's very honest in saying that they have no clue how to do the second one. And the problem with the second one is that I got to factor it out with the 8 the question is, do you actually have to factor out the 8? Or is there another way? Because, the thing with the second one is that you're setting up your generic square. You can't do that with 8x squared, right? Because 8 is not a perfect square, right? So you can't, if this were 9, then maybe, right? Because 3 times 3 is 9. So there's got to be another way to figure this one out. We'll come back to this one later, okay? So we're looking at the do now here. Let me just make sure my camera's lined up so you actually see the work. Okay, good. Let's talk about 9.4 part A. Okay, so this one here, just to check yourself before you wreck yourself. We had plenty of participation in yesterday's class here, okay? So I got my x squared, I'm going to put it down there. Now I'm going to complete the square. So what's going to go here? What's going to go here? Well, if I take this -2x, I'm going to lay out one of those negative x's. And then my second negative x right there. So I'm trying to complete the square x minus 1 squared so that I can take a square root of both sides and yes, find the solutions for x here. Okay, so remember, this is not a function, right? I don't have an x and y relationship. I just have an input there. So there's got to be some inputs that get this whole thing equal to 1. Some solutions here, okay? So anyways here, I need to get this up to what? Let's get some volunteers here. What does this need to become? 1, yes! -1 times -1 is 1. And I have -3 right here on the left side. I don't have a complete And this came in from Bolding. I had to redirect the Block 6 class about this here. That if you read from last lesson, problem 9.3, which is right here, they talk about how to write your answers. Okay, so when you use this form, a lot of times you end up with a square root in your final answer like this, and that's because you end up with something called an irrational answer. Not a rational answer. You end up with irrational answer. Look at it in bold. Okay, irrational numbers; those are numbers that can't be written as fractions. Okay, of integers, fractions of integers. So anyways, irrational numbers can't be written exactly as a decimal. Okay, they can the decimals. If we try to change the decimal form, they would continue infinitely and never go into a repeating pattern. They never repeat, right? So the pattern, we can't detect it, so we can't really write it out as a decimal completely accurately. Okay, so that's why we call this exact form. This is my answer in exact form. We also call that radical form. Okay, because this is the best way I can write this out. I can't take the square root of 5 and get a really clean number, so I just leave it like this. 1 plus the square root of 5, which is approximately 2.16. Okay, that's an approximate decimal form of 2.16. Or my other answer is 1 minus the square root of 5. Okay, square root of 5 is about 2 over 2, 2.16. So 1 minus 2.16 will be about negative 0.16. So if you got those and you wrote those as your answers, those are called the approximate decimal form answers. So you don't really want to write it as that. You want to leave it like this, just because this is the most accurate way to really describe that number. Okay, let's look at the second one. We figure out the second one. What do we do? It's really ugly. It's not that ugly if we figure it out. We might have to do it. 69.5 is like negative 5 plus or minus 3. No, it's going to be nice and clean once we get to the answer. Okay, let's check this out here. Well, the way it's written right now, the hints I told folks, if you folks figured it out, just fuck it right now. The way it's written right now, we can't actually complete a square. So we need to figure out how we can rewrite this so we can actually write a perfect square. Okay, on the left side. Now, we're never going to have it with the square there because the square root of 8 is like, it's an irrational number. Okay, so anyways, there's a trick to doing something to both sides. And keep in mind, guys, the only way that I taught you to complete a square so far is we've always had that in the bottom left corner. We've always had just 1x squared in the bottom left corner. So, thoughts on what we do? I don't think that's true. I get it kind of there, right? So, I think you're thinking factoring out the greatest common factor, and that would be 2 for this. We don't have to worry about facts, so we want to get this down to x squared. So what can we do to do that is this. If we divide both sides by 8, right? It's not a perfect square yet. No, it's not a perfect square yet. So this is 230. Yeah, 238 over 8 isn't even a whole number, right? When you divide it. Okay, so let's just see here. So I've only taught you like this will come up in problem C of question 912. Okay, but when your front number here is right is not 1, I need to divide. Okay, equation, right? The whole thing. Okay, by A. Right? A is right. We were talking about standard form today. Talking about perfect square form today. But anyways, when A is not 1, you have to divide the equation by A so that A equals 1. So that I can actually do the methods I showed you so far. Okay, so if I divide this left side by 8, remember if I divide one side by 8, I can divide the whole side by 8. And then I divide the other side, the whole side by 8 as well. It's easier over here than it is here. But anyways, 8x squared divided by 8 would just be x squared. Okay, 8 goes into 45 times, so this becomes 5x instead of 40x. This goes into 5x. And then over here, I know 8 would go into 24 3 times. So 8 would go into 240 30 times. So we're not quite 30 times. This is actually 29.75 if you divide that using the calculator. Okay? And this is the neat thing here, I guess. This is why it becomes easy, right? You asked, is this an ugly thing earlier? And it ends up not being that. It looks ugly now because we have decimals, but alright, so I'm going to complete my square right now. Okay, I have the 5x here, so I'm going to do 2.5 of those. One above is that now we have a whole number on the right side. Okay, so I'm going to add 6.25 to both sides. So now I have x squared plus 5x plus 6.25. And that equals, well, 6 plus 30 would be 36. And, you know, it's basically 30 because we have 1.25 and 1.75. Anyways, here. Yes! Okay, so now we have a perfect square on the left side. Here, we're going to write it in perfect square form. X plus 2.5 squared is equal to 36. And we have a perfect square on the right side, right? Because 36 is just 6 times 6. Okay, so this is, we're going to have rational answers here, not irrational. Okay, so I take the square on the left side, I'll take the square on the right side. We can't forget them. Yes! The plus or minus. Okay, and I get x plus 2.5 equals plus or minus 6. Okay, so now I just need to take away 2.5 from 6 and take away 2.5 from negative 6. Got my answer. So I get x equals negative 2.5, or x would also equal 3.5. So excited. Questions? All right, let me make sure my video is still working. So that I'm just not. Yes, okay, we're 13 minutes in. So this is going to end up being about as long as the actual lesson is here. Okay, any questions on that? All right. So what we did here is go ahead and read our objective of the day. Who's got me? Who's got me? Feel free to. I'll read the objective today. Let's put our one student volunteer on the spot. Okay, our objective today, students will be able to learn how to use the quadratic formula to solve quadratic equations. Okay, so this is going to be the granddad, the most well-known one. If we look over here, just to remind us, what are the 4 ways? Okay, what are the 4 ways we have? Well, we're adding quadratic formula today, but what do we have so far? Well, we got easiest way. Okay, when written in standard form, you can factor it, right? Solve by factoring. Okay, and then use the zero product property to solve a quadratic equation. Okay, and then you know, how do you check to make sure your answers are right? Well, you can graph. Right? You can graph the parabola, and if it's set equal to 0, which they weren't in this one, these problems there, but if it's set equal to 0, you just look at the x-intercepts, or you look to wherever y is if it's not set equal to 0. Okay, so graph. Okay, we also have what we just did right here. Okay, which is completing the square. So write it in perfect square form. Okay, you're going to learn what perfect square form is on the classwork today, and then you just take a square root. Okay, taking square root after that. All right, so those are the 3 things that we've been working on the past few days. What you're going to do today, the very last method, is the most well-known one. Okay, the quadratic formula, and it's a good one. Okay, it can help you solve pretty much every quadratic equation. Okay, but the thing is that sometimes these other methods are easier. Okay, which is why the textbook wants to know these methods first, because although you can use the quadratic formula when you learn today, pretty much whenever, factoring sometimes is easier. Right, you make fewer mistakes. Okay, same with the other methods. Okay, all right. So anyways, what you got to do today? Let's switch to what you're doing today to make up class. Okay, let me go ahead and erase the board, and we'll read these together. You're going to work on pages 421 to 422. You're going to do problems 9, 12, and 9, 13. All right, you're doing that on your own, unfortunately, because of the assembly here today. And then 9, 14 we'll do together. You and me. All right, everybody's watching this video. So yeah. Okay, so do 9, 12, and 9, 13. There's no checkpoint here. You just kind of do it on your own. So get started on that. Ready, set, go. Okay, pause the video. Try 9, 12, 9, 13. Okay, work on it. Work for a bit. Pause. Okay, now unpause, and I'm going to go over them. Okay, I'm going to go over them. So I'm going to do this a little bit fast. Doing 9, 12, 9, 13. Now, I don't think there's really much for me to go over. If you really tried them, you might have got stuck in class. You might have asked questions if you were here. So maybe let me just find the problems on here just in case there's stuff. Okay, cool. So some things that would have happened in class as we went over these. Okay, I did this, honestly, I did this one, and I did this one in class. Okay, again, try the problems before you watch this part, please, so you get context here, okay? Because in this part of class, as people were working on this, I was writing this up on the board. Here, I was writing this. Okay, which I was writing, I really should have written up. All right, now that you've given it about 5 or 10 minutes of work on question 912, let's go over it pretty briefly. Or long, we'll find out. All right, so in this problem here, you have a quadratic equation. How do I know it's quadratic? Well, the x is being squared. How do I know it's an equation? I have an equal sign. How do I know that it's not a function? Well, there's no y. We have it set equal to 3. So that means we're going to find the solutions for x. Or wait a second, do we have to? What did it say in the directions? Okay, it said you didn't actually have to formally solve them to get the final solution. The point of this question was, well, to practice solving, but also just to figure out how many solutions there are. So at what point of solving do you really figure out how many values there are of x that make this equation true? Okay, so we don't know that kind of right away. So we should maybe just try to solve it here, okay? So what do we have to do? Well, we want to write it in something called perfect square form, okay, which I have up here. So forms of a quadratic equation. You all know the standard form. Standard form is going to become very useful to us in a second when we do the quadratic formula. But standard form is also useful for factored form as well, because usually we don't see any parentheses. We factor it and then use the zero product property to solve. Okay, the method we're going to use here today isn't factoring, it's completing the square and setting it equal to a number, a constant over here in perfect square form. And then we should be able to figure out what our answers are and how many there are pretty easily through some tricks, okay? Quick note here about the different forms of a quadratic equation in case you are copying this down to your notebook. The standard form has coefficients a, b, and c. Perfect square form has coefficients a constant here, b, and another constant c here. But note that a, b, and c, they do not represent the same thing. In fact, they do not equal the same thing as you manipulate forms. They're just supposed to represent kind of the structure of the equation. So this is written in neither because it's not set equal to 0, so it's not standard form, but we're going to use the perfect square form to figure out how many solutions there are, and hopefully you already did this. So if I have negative 6 x's, I'm going to put negative 3 of them here and negative 3 of them here to set up a square. I'm going to have x minus 3 times x minus 3. Okay, and so now I need to figure out what I need to change this number to complete the square on the left side. Negative 3 times negative 3 is positive 9. Do I have 9 there? Well, I have too many tiles, so I'm going to take away 1 from both sides. And now my left side will be that perfect square. X squared minus 6x plus 9. Okay, my right side changed from 3 1 tiles, and I had to take away 1 to complete the square on the left, and that is my right side here. Go ahead and rewrite this one in perfect square form, okay? So I have to do that first before I can figure out how many solutions I have. Well, x squared minus 6x plus 9, we proved that that is equal to x minus 3 squared. The quantity x minus 3 squared is equal to 2. Okay, at this point, did you figure out how many solutions there are going to be? Why at this point? What did you have to do to keep solving this? Well, if I wanted to figure out what x would have to equal, where if I squared x minus 3, I would get 2. Well, if I want to figure that out, if I want to solve for it, I'm going to undo that squaring. So I'm going to take the square root of both sides. But what can I not forget? Do not forget this. That's right, a positive number has 2 values. 2 different values could be squared to get to positive 2. We got the negative square root of 2. If I squared that, it'd become positive 2. We have the positive square root of 2, about 1.4 or so. If I squared it, become 2. So here, you could keep solving this if you really cared about it. But the point of this problem actually was to figure out how many solutions there are. And I would argue, and teachers' arguments are generally right, they've studied this for a little while, that it was this step. As soon as you got to this point here, or maybe this point here, you knew that there were going to be how many solutions? 2 solutions. And why is that? Well, plus or minus the square root of 2. Plus or minus the square root of c, that constant term. That's right. Any positive value has 2 square roots, so we end up with 2 solutions. Let's check out part B real quick, okay? This is 912 part B. because something different happened on this one that led to maybe you didn't have to work quite as hard on this one. You didn't have to do quite as much. So we have m squared here, okay? We only have one of the quadratic terms. That's easy for us. We don't have to divide or anything like that to complete a square. Okay, I'm gonna put 6m's here. I'm gonna put 6m's here. That means I need to change that 36. 6 times 6 is 36. Oh, sorry, 37. I need to change it to 36. So what do? I'm gonna subtract 1 from both sides. And I'm gonna get m squared plus 12m plus 36 is equal to -1. Now you might be thinking, are there gonna be any solutions at all? All right, so m squared plus 6m plus 36, well, that's the same thing as m plus 6 squared. Okay, right side here is equal to -1. Okay, so be careful here. Here's where you need to be careful. Why do you need to be careful? What am I gonna do to solve for m? I'm going to square root of both sides. And wait a second. What's wrong with that? No two numbers multiply themselves to become -1. So how many solutions are there? Oh, can't take the square root of a negative number. There are 0 solutions. Part B. I'm not going to do part C. I'm not going to do part D because I didn't do that with classes here. But maybe I volunteer real quick. What'd you get for the answer to part C to 912? How many solutions were? I got 2 for all mine. You got 2 for all of them? Where's your textbook? Show me your respectful textbook. Where's the respectful textbook? I just thought all of them. Okay. Well, this one here, if you were doing this one here, I divide everything by 4, right? Divide everything by 4, and you get p squared plus 9p is equal to 4 goes into 81. Well, that's a decimal here. One of these. Oh, this one here. This is the one. I forget. I think you get 2 for this one. You get 2 solutions on this one. This one here, you get. Oh, you get no solutions on this one. What? Right?
I did one of them.
This was not a problem when everybody was doing it in groups yesterday. I think I think this one here you get 0 solutions, and the reason is, sorry, one solution. The reason is when you wrote this in practice. I guess we're doing another problem. Okay, we're doing part C of 912 because I was hoping I could just get somebody to do it here. Okay, we got 912. Part C. Thank you. 4p squared plus 36p. Equals 81 or positive 81? Negative 81. Good. Okay. Cool. All right. So what I'm going to do, that I'd recommend to do, is divide both sides by 4. Okay. And I'm going to get p squared plus 9p is equal to -20.25. Lovely. Okay. So we have some decimals there, juicy decimals, and then we're going to have more decimals here when we fill out our generic square. Okay. P squared. Okay. 4.5p. 4.5p. So the perfect square I'm going to try to create is this one. P plus 4.5. And cool. And then so 4.5 times 4.5 would be what? Is it 20.25? It is, right? No. Is it 20.25? It is 20.25. Okay, so it's 20.25 here. So I can get 20.25, not actually by adding anything, well, actually adding 20.25 to both sides. So here we go. If I add 20.25 here, right, we've seen that right there. I'm canceling out the right side. Okay? Right, that becomes a 0. So now the left side here, I got p squared plus 9p plus 20.25. is equal to 0, written as a perfect square, my friends, is p plus 4.5 squared is equal to 0. Okay, and when I take the square root of both sides, how many square roots of 0 are there? Just 1, because the square root of 0, well, 0 times 0 is 0. Does 0 have any signs? No, 0 does not have any signs. So that means if I put that plus or minus in front, it's not going to give me 2 numbers. It's just going to be 1 number. So my answer here is going to be p equals -4.5. Only way to get to 0. So we have here 1 solution. Okay, 1 solution for that one. I think there were no solutions. I can't remember. We don't really need to go over D. But the big takeaway is this one right here is that, you want to work, what's the saying? It's work smarter, not harder. Okay, work smarter, not harder. In that, if you're sitting down to do this, okay, perfect square form, you might even have 2 solutions. You might have 1 solution or no solutions. Okay, so let's fill this out here. maybe add it to your notes here real quick. Perfect square form, okay, when C, okay, so C here stands for constant. It's the number on the left side here, sorry, on the right side here that the perfect square is equal to. Here, 2 in this instance and -1 in that instance. And, no, you're not in the video, don't worry, 0 in that instance here. Okay, and if I take the square root of a positive number, I'm going to get 2 solutions. Okay, if C is positive, there are 2 solutions. What about if C is negative? Well, I'd have to take the square root of a negative number. I can't do that. I would have 0 solutions. Okay, if C is 0, 0 has no signs, so there are 0 solutions right there. Okay, so that is 913. We're going to do 914 next. Message me if you have any questions. Oh, this is incorrect. 0, there's 1 solution, not zeros. All right, there we go. There we go. Yes. Okay, any questions? Please message me. And now we are on to question 913 and 914. Now, I know the last slide said I was just going to do 914 as a class together, but I did get questions about 913. Quite a few of them during the 6-block class. So perhaps we should talk about 913 very briefly. Okay, so 913 talks about the granddaddy of them all, the quadratic formula, which can pretty much always be used to solve a quadratic equation. It's not like factoring where these can be factorable. Okay, or clean square, clean square, you just need the x squared term to use the 1. Okay, so it's okay if a isn't 1 in this here. Okay, so the quadratic formula is going to be used. It needs to be written in standard form. Okay, standard form. Right? Standard form here. Okay, we have that up on the board. We had that. We talked about that earlier. Okay, standard form is when I have it written without parentheses and ordered from the x squared term, right? I could have a certain number of x squared terms, like 5x squared or 2x squared, a certain number of x terms, and then a constant. So 5x squared plus 2x plus 9, right, equals 0. It needs to be set equal to 0. That's a very important part there, okay? A, B, and C, right, the coefficients here, the part in front of the variables, and then the constant are very important for this formula, which is a magical formula, isn't it? Okay, you're going to see this where our last lesson of the year actually has us prove the quadratic formula as to why it gets us solutions. For now, we just plug in, we use it. We trust the math gods in as to why this equation works. Again, when our equation is written in standard form. Let me check that my camera is pointing to the right place here, which it is. Okay, what we're going to do here, we're just doing nice and quickly. Okay, down here, I kind of snuck it in there. Hopefully you've done this. It says carefully substitute A, B, and C from the quadratic equation. X squared minus 3x minus 7 equals 0 into the quadratic formula and solve for x. So let's just do that real quick together. We can do that over here. Here, let me move it over here. What form is this written in? X squared minus 3x minus 7 is equal to 0. What form? Well, there's no parentheses. Hold on one second. Hold that thought. Yes. Done? Yes. Okay, cool. Wonderful day. Thank you. So what we need here to use this magical formula to solve this is we need to know what A is, what B is, and what C is. For the in the context of that equation. Okay, one second. Guess what A is here? Well, I don't see a coefficient, so it must be 1. Right? I just got 1x squared. So A here is 1. B is what? Well, it's negative 3. Not positive 3, it's negative 3. Okay, and what about C? Well, I have my constant here is negative 7. Okay, so that's my C. Okay, check it out. Here's how it works here. I just take x. And there's a song for it. Remember it. When a squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to get extra credit if you sing that song in front of the class. It's worth 5 points, 5 test points. Okay? If you sing that song, you have to have this formula memorized. Okay? There's actually a little project too. You can do an independent project if you want to get credit on quadratic formula. I'll say more about that later. Okay? So we check it out here. This is really just a plugging in thing. Okay? X equals negative b. B is already negative, but you know, negative, they need the opposite sign. So negative a little bit confusing. So signs do matter. So negative b plus or minus the square root of b, and b is negative 3, b squared minus 4 times a times c. Okay, a is positive 1, and c is negative 7. Okay, all over 2a, so 2 times by 1. And that's it. That's what it. Those are your answers. What? Those are the answers here? Okay, yes, this is technically the answer here. It's just not simplified. So really, all you have to do is plug in a, b, and c, but then you have to simplify. Okay? One of the reasons why they gave you those problems at the beginning of class, question 9, 12, is to already think about, well, part of the quadratic formula is important because it shows us how many answers we're going to have. When we did that work earlier in class, at what point did we know if we had 2 solutions, 1 solution, or 0 solutions? When we took the square root. Okay? So anyways, if you, this step is to simplify this, right? Simplify this here. The part to simplify first, the 0 and 9 is this square root here. That's the part you're going to want to simplify first, and that's what I'm going to do as my first step. So I'm going to start simplifying this. Okay, x equals negative b. So I might as well simplify this here too. So negative negative is positive 3, right? Negative negative makes a positive. Okay, plus or minus the square root. Okay, so I don't know what this is here. I'm going to figure out what I need to get the square root of in a second. So how do I do that? Negative 3 squared is 9, right? Negative 3 times negative 3, positive 9, good. And then I got to take away 4 times a times c. Okay, 4 times a times c. What is 4 times a times c right here? Well, ignore the negative for a second. Okay, 4 times 1 is what? 4. 4 times negative 7, right? So we order, we multiply 3 things in a row, we multiply the first. The second is 4. 4 times negative 7 is negative 28. I got to take away negative 28. I'm taking away negative 28. So I'm taking away a negative number. How else can I write that? Well, taking away a negative number is the same thing as adding the positive version of that number. Okay? So how many solutions am I going to have? You can probably figure that out right now, right? 2 solutions. Okay, there's going to be 2 solutions because, check it out, when I simplify this times square root, I got a positive number, plus or minus. But see, plus or minus comes in there. Plus or minus is in the quadratic formula already. Set up for it, okay? So anyways, simplify your square roots fully. 9 plus 28, okay, I'll keep going with it. 9 plus 28 is what? 37, okay? And 37 actually isn't a perfect square. It's close to it. So I can't really simplify it more than this, okay? All over 2a and 2. What's 2a? 2 times 1 is 2. That's my final answer. I'm going to leave it like that, okay? This is my answer in exact form. Box it up because it's my final answer. If I wanted to know approximately what decimal that was, I'd have to do 3 plus the square root of 37 in a calculator and then divide by 2 and then see decimal. And I'd also have to do 3 minus the square root of 37 divided by 2 to get the other answer. 2 solutions there. Now, okay? Questions? Think about it. Are we going to get more examples? Yes, we will. We will definitely get that right now. Okay, let me switch slides here. We got question 914, which is just bringing us back to kind of why we're doing this, and also doesn't want us to forget about these beautiful methods we've developed over the last few days here. What other methods can you use to solve a quadratic equation? Well, this one here is not factorable, so I can't use factoring, but of course, factoring is one. Oh, there's factoring right there. Is one that you're going to want to use because you can avoid all this mumbo jumbo, all this plugging in, taking. This is, you know, a lot of you guys probably made mistakes on this doing this the first time. Okay, I know we've solved equations that look like this on homework. Okay, because putting the numbers in is half the job of simplifying. Okay, but anyways, it's nice to avoid this by factoring if you can. Okay, and then using zero product property to get your answers. Okay, there's also graphing too. Don't forget about that one here. The Desmos, right? If I graph the equation y equals x squared minus 3x minus 7 to Desmos, I can just look at the x-intercepts. Okay, to figure out what my solution to that equation would have been. There's completing the square. Yeah, I could have used completing the square on that one. X squared is just 1x squared, but then I'd have negative 3 in the middle. Decimals, you know, kind of messy. So graphing, finding x-intercepts, roots are the particular x values that go with the whatever the function is. Proofs. Get used to them. Love them. When you're potentially in my class next year, there's gonna be so many proofs. They're really gonna move you a little closer to that there. Okay. So we got the proof of the quadratic formula in front of us. Okay. So when you're solving a quadratic equation, you can try to just graph it. Okay. You can graph it out there, but I don't really use that. You can try to factor use the zero product property. What if it's not factored? What if it's hard to complete the square? Well, or you can just use that formula. You can always set something up in standard form and then just use the formula to get your answers out to be simplified. Okay. And here's why you can do that. There it is. That explains the whole thing. Okay, so what we're looking at here is something called the proof in geometry class. And pick on it. I have a geometry student in my other class. I pick on them. Just like, hey, you love these proofs, right? Okay, the way proofs work is they give you something, and then you make a mathematical case about why another thing is true, so that you can then follow this as a rule, knowing it's been proven. Okay? So a very last lesson of this year, we're actually going to prove the quadratic formula. Okay, so actually, wait, what form do you need to have the equation to use the quadratic formula? That's right, standard form. Okay, so in standard form, right, when ax squared plus bx plus c equals 0, we can make a case that this is where my solutions are. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And why? Why is that the case there? Well, if I'm written in standard form, x squared plus bx plus c equals 0, then I can multiply both sides by 4a. And over here, 4a times 0 is still just 0. And I have 4a squared, x squared plus 4ab, x plus 4ac. And I can do something called completing the square, adding b squared minus 4ac to both sides. So I complete the perfect square called 2ax plus b squared equals b squared minus 4ac. And here's my perfect square, and that's what that looks like. And then I take the square root of both sides, and I end up with two solutions, which are 2ax plus b equals plus or minus b squared minus 4ac. And then I subtract b from both sides, and I divide both sides by 2, and I end up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So just use that. Just use that. But there is a mathematical argument here as to why this equation works when it's written in this form. This is how they're connected. The last lesson of the year, you're going to provide reasoning for that. Okay? So, take the rest of the class. Well, actually, wait a second here. This is my song here. Wait for it.
B squared minus 4ac all over 2. X is equal to negative b plus or
Extra
minus
credit if you
the
sing
square
this.
root of b squared minus 4ac all over 2.
5 test points.
X is equal to negative b plus or minus the
gotta
square
memorize it.
root of b squared minus 4ac all over 2.
Solve those quadratic equations. When written in standard form.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
It's like I'm relieving this guy. That's a great song. Alright, anyways, quadratic form. So, okay, wrapping up class now, guys. You've had a long enough day with the assembly and other stuff like that. Okay, so you just got to finish questions 9:15 and 9:16. There's a checkpoint after 9:15. Some questions you might be asked. What's the most important step in the quadratic formula? I think the answer to that is really to take the square root part. And how can you tell when a quadratic equation has no solution? Well, you're taking the square root of negative number. And then you just say no solution there. A parabola, that would mean there was no x-intercepts. It's above the graph. Those x-intercepts are imaginary. Okay, so do 9:15, 9:16. And I think I gave one more example in class after. So pause the video. Try question 9:15. Check your answers on Desmos by looking at the parabolas, and that's question 9:16. Okay, but I will give this as one more example. So try the problems first, then watch this to see if you got it right. Okay, so why can I write this in a quadratic formula? Well, it's written in standard form. Okay, what's my A? What's my B? What's my C? A is 3, B is 7, and C is 2. no solution here. We'll see why in a second, okay? So I can just plug on into this magical formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're just plugging in. That's half the job with the quadratic formula. Okay, so I'm going to plug in my a down here, all over 2a. A also goes here, right? A will go here. Okay? B is x equals negative b plus or minus the square root of b squared minus 4ac. C just goes in one place. So C will go here, and then boom. Those are my answers. It's just not simplified. So that's the next part of it. 50% of this is plugging in, 50% of this is simplifying. Okay, what do I zero in on? I'm going to zero in on the square root part. Okay, because that's going to tell me how many answers I have. Square root positive number, 2 answers. Square root 0, 1 answer. Square root negative number, well, I can't do that. No solutions. Okay, so I end up here with x equals negative 7 plus or minus. Okay, zeroing in. I'm focusing on the square root part. 7 squared is 49. Okay, now I'm going to subtract 4ac. 4, 3, and 2 are all positive numbers, so I'm going to subtract a positive number. This video will be done in 1 minute. Subtract 4 times 3 times 2. Okay, so I'm subtracting positive numbers. That means I'm subtracting positive numbers. I'm going to subtract here. That's why there might be no solutions. But wait a second. 4 times 3 is what? 12. 12 times 2 is what? 24. Okay, 24 is smaller than 49. This is going to be positive here. So I'm still going to have 2 solutions. All over 2a. Okay, x is going to equal negative 7 plus or minus the square root. What's 49 minus 24? 5. That's good. 25 is a perfect square. Okay, all over 6. Okay, so this equals negative 7. What's the square root of 25? It's 5 plus or minus, right? You value the square root part, right? That's the perfect square it is. It's 5. Okay, all over 6. And now I just need to set up 2 equations to solve this one. Negative 7 plus 5 over 6 and negative 7 minus 5 over 6. Okay, and I get what? Negative 7 plus 5 is negative 2. Negative 2 over 6. I get negative 1/3 there. That's one of my x's, and I get 7 minus 5. Negative 7 minus 5 is negative 12 over 6, and 12 over 6 is negative 2. So those should be your 2 answers for part A. Okay? Message me if you have any questions. Quadratic formula. Solve a whole bunch of stuff. Let's take a look and see what your homework is. There it is right there. Okay, so thank you for watching this video and turning in your classwork. You have to turn your classwork to Google Classroom, but your homework will show in class tomorrow. Have a good day, guys. Bye.